So in this section we will cover about the network interfaces. So what we'll cover, the objective is compare, contrast the OSI model and the encapsulation concept. Encapsulation and decapsulation we have discussed already, but again give a scenario, troubleshoot the common cable connectivity issue or select the appropriate tool. Here we will discuss only the tab. Then use the appropriate network software tool. It may be the TCP dump or the Wireshark. Okay, so how we will use these tools we will discuss. But right now first we are going to discuss about the interface card. Network interface card. You can see this type of the network interface card where is a RJ45 connector used to connect the cable. Right, so this network interface card is a responsibility to make the connection or the connectivity between the other devices. So these are the interface card. Some cards support to the copper cable and some are supporting to the fiber optical cable. And these card also follow some standard Ethernet standard where we have discussed about the 10 base T and something, right? If you remember 10 base G, 100 base G or 10G like this. And there is a possibilities having the multi-port. Multi-ports means having the multiple port like the switch. If we take an example of the switch, so switch have the 24 and to 128 ports and more. It's depend. So each and every port have a network interface card like this. If any switch having the 24 ports, it means it have the 24 network interface card. And every network interface card have its own memory for the calculation, collecting the data, transferring the data and all. This card basically working off the data link layer, but there is a two terms. One is a driver, another is a physical port. Because only connecting the physical port will not able to activate or will not work until the software will not installed or the driver will not installed. The network interface card will not work. So there is a two things. One is a driver actually working off the L2 layer 2 on the data link layer, and there is a hardware also exist. The hardware is a physical address or working over the physical layer. So one thing is a Ethernet framing and the hardware. So what is the Ethernet framing? Frame, all of us know about the frame. Frame is making on the layer number 2, having the MAC address of the source and MAC address of destination. So both adding the MAC addresses on the packet known as a framing, means adding the MAC addresses on the packet known as a framing. It is called Ethernet framing. There is a possibilities of adding the media access control MAC addresses, or it is called Ethernet addresses. Sometimes it is known as a EUI, extended unique identifier, because as we have discussed, MAC address is a unique address in the world. Right, so how the Ethernet frame looks like? Ethernet frame have the preamble, SFD, destination MAC, source MAC, Ethernet type like which standard it is follow, and here is a one is a payload. So what is the payload? Payload nothing, just a value of the size of the data size. This is the actual data size which is going to be transferred. Other will be headers. Headers we have discussed already in a detailed in previous sessions. Okay, and FCA for the checking of the any type of the error. So if we talk about the media access control or the MAC address, so MAC address is a size in a 40-bit size, 48-bit or the 6-byte size. It is actually written in a hexa notation. Hexa notation is a value, or it is called hexadecimal value. So I think all of you know about the hexadecimal value, where 0 to 9 and then A to E. F, E to F. F is a final destination. So that is the reason there is a broadcast domain is a F, and F. So how you can check out? I have already shown you to capture the data and then check out the hardware addresses. MAC addresses of the source and MAC addresses of the destination. Where is the destination? Actually, it is the broadcast message. That is the reason there is a only F. Okay. Here is a some frame length and the MTU. MTU actually known as a maximum transmit unit. The maximum transmit unit is a 1500 byte. From where? Payload. Payload is equal to 1500 bytes. This is the size of the payloads. And other size is a header size. And if we talk about the Ethernet type, so there is a different type of the protocol or using different type of the size. Like IPv4 is a notation of the 2048, and in a IPv6 there is the value is 0 into 86DD. There is a different type of the Ethernet type. Here is Ether type and this is the Ether type for the IPv6. And I hope you know about the IPv6. IPv4 is the previous version of the IP address. What is the IP address? IP address is nothing, just a logic identification of the LAN card. LAN card or network interface card. Which have network interface card we have discussed already. Here is a two address. One is a logical address known as a IP address. Another is a physical address known as a MAC address. There is a different of the size. Maximum size is a 1500 bytes, but the lowest size it will be 64 bytes. In the detection CSMA or the CD detect the collision, the size is a 64 byte. Including the headers means there is a 1500 bytes of the payload size and total size is a 1518 bytes. And some frame known as a jumbo frames. Jumbo frame is a frame which is actually carrying the data of the size of the 9000 byte. Like when the data is transferring from the one computer to another computer in a lower standard or the basic standard computer are using, the size of the frame is a 1500 bytes. But other type of the standard or the high standard type of the devices or the network interface card carrying the data of the size of the 19,000 bytes in a single frame. 9,000 bytes in a single frame. These frame known as a jumbo frame. Now the question is that if the data is traveling in the network in the form of the packet or the frame, so how you can sniff the data? Why you need to sniff the data? Actually, as a network security engineer or a SOC analyst or the security analyst, it is necessary to capture the data and then check what type of the data it is. So capturing the data, there is a two possibilities. One is a sniffing by the sniffing method, another is a taps method. So what is the sniffing? Sniffing actually some type of the data when traveling in the network will be captured by the third person. This third person may be the hacker, or this third person may be security researcher. So security researcher and hacker both can capture the data by using the sniffing mechanism or the method. There is some tools can be used which is actually protocol analyzer, which is decoding the frame and the protocol headers and the data. Means, as you know, data is traveling, but actually traveling in a format of the frame. Frame has a two value. One is a header, another is a payload or the data. So decoder has a capability to capture this frame and then separate the header and the payload both. So it is possible by using some softwares or the other techniques. So packet sniffer may be the hardware or maybe the software. These sniffer have a capability to read the frames from the network including the wired and the wireless, both wired and wireless network. This packet sniffer have a capability to capture the data from the wired and the wires. There is a multiple types of the sniffing can be stable. They can be host based, they can be span or the mirror port, or they can be tap. So what is the host based capture? Host based capture means there is some devices, like this is the network and here is one device is connected. This is the Windows system and here is another device is connected. This is the Linux system. Okay, if I want to capture on data on this, because I am a security researcher in a organization, so I am an authorized person to capture the data from this host. So what I will do, I will start the capturing, and this capturing will known as a host based. Means if I want to capture the data on any target host, it will be known as host based capture. It can be Windows, it can be Mac, it can be Linux. But there is another mechanism or the method, it is called a switch port analyzer or the mirror port. So actually all of you know about the hub. Hub is broadcasting the data. But there is a two port, one is a gate 1 G1, another is a G2. Actually this is not gate 1, this is the gigabyte port. Gigabyte 1 and gigabyte 2. Okay, here is a one more port, it is called gigabyte 10, G10. Here is a security researcher or a workstation for the security analyst or security analyzing. So what I will do, I will access the switch and make some configuration and make here the mirror port. So what is the mirror port? Mirror port actually, mirror port, just any data to come on this port or going out this port will be transferred or will make a copy and transfer to the G port number 10. So the person who are sitting here will capture all the data which is ingress or the egress communication. Ingress egress means communication inside and outside, both incoming traffic and outgoing traffic. If I will make the mirror port of this port G2, so it will also send one copy to the G10. This is called mirror port or the span port. There is a one other type of the port. It is called test access port, tap port. These are actually accessed in a firewall, exist in a IDS and IPS, and also it is capturing the data with a passive mode. And there is a both type of the mode exist, passive and the active. Passive, when the destination port don't know my data is going to be captured, it is known as a passive. If they know, it is called active mode. So there is a one tool, it can TCP dump. TCP dump have the multiple options like -I, -w, -bb used for the capturing the data. TCP dump -I and ETS0, it will start to capturing the data. The another option is -w. -w is a write the data, and -r can be used to read the data from the file. For the example, if you are capturing the data and the screen is a full and you are not able to understand what is going on the screen. So what you can do, you can dump all the data into a file. Later on, you can read this file and analyze the data, what is going inside the network or going outside the network. There is some filters can be used at the time of the capturing the data, like host, net, port, source and destination address, source IP or destination IP address, specific protocol like ARP, ICMP, IP, IP6, TCP or UDP. And also there is some operators can be used like and, or, and not. I think all of you know about the and, about the or, about the not. For the making a group, you can use the parenthesis. First and the second type of the filter used here. Wireshark, I have told you already how to use Wireshark and capture the data.